Welcome to today's education briefing. We're looking at 3 ideas that connect directly to student life and the future of work: compound interest, machine learning in education, and artificial intelligence ethics. Let's begin with compound interest. It is often described as earning interest on your interest. That sounds simple, but the effect becomes powerful over time. Imagine investing £100 and earning 5% each year. With simple interest, the growth is calculated only on the original £100. With compound interest, each year's return becomes part of the amount that can grow next year. After 1 year, £100 becomes 105. After 2 years, the 5% is calculated on 105, not just on the original deposit. The difference may look small at first, but over 10, 20, or 40 years it can become substantial. This is why starting early often matters more than trying to make dramatic investments later. The same principle can work against you. Credit card balances and some loans can compound too, meaning interest is charged on a growing balance. So the practical lesson is not simply invest more. It is, understand the rate, the time period, the fees, and the risk. A budget helps you create a regular surplus, while an emergency fund can stop an unexpected expense from forcing you into expensive debt. Financial literacy is really the skill of making small, informed decisions repeatedly. Our second topic is machine learning, a branch of artificial intelligence that is becoming part of education itself. Recent discussion about teaching Python, machine learning, and AI to younger students reflects a wider shift. Students are not only learning how to use digital tools, but also how those tools work. A neural network is a useful mental model. It is made from layers of connected mathematical units. During training, the network receives examples, produces an answer, measures its error, and adjusts internal weights. Repeat that process many times and the system can become good at recognizing patterns, such as a handwritten number, a spoken phrase, or a suspicious transaction. But machine learning is not the same as understanding. A model can find patterns without knowing why they matter. Its performance depends on its training data, the way the problem is defined, and how its results are checked. That is why learning the basics is valuable for everyone, not just future programmers. Students who understand data, probability, and model limitations are better placed to question an impressive-looking answer. The best classroom approach combines experimentation with reflection. Try a model, inspect examples, compare predictions, and ask what might be missing. Treat AI as a tool for thinking, not a replacement for thinking. That leads to our final topic, AI ethics. As AI appears in hiring, healthcare, education, and everyday search tools, technical accuracy is only part of the story. We must also ask, who benefits, who could be harmed, and who is accountable when a system is wrong? One major issue is bias. If historical data reflects unequal treatment, a model trained on that data may reproduce the pattern. A system can therefore appear consistent while still being unfair. Other concerns include privacy, unclear explanations, copyright, security, and the environmental cost of large-scale computing. There are practical ways to respond. First, use data carefully and check whether important groups are represented. Second, test systems on more than one type of user and measure errors, not only average accuracy. Third, keep a human review process for high-stakes decisions. And finally, be transparent. People should know when AI is involved and have a meaningful way to challenge an outcome. So today's 3 lessons fit together. Compound interest shows the power of repeated choices. Machine learning shows the power of repeated examples. AI ethics reminds us that powerful systems still need values, evidence, and human responsibility. Keep asking good questions, check the numbers, and use technology thoughtfully. That's today's education briefing.